In this video, we're going to be looking at solving exponential equations. Now remember, the key idea about solving an exponential equation is to make sure that each side of the equation has the same base. Alright, so if I look at what I have here, I have 1/8 and I have 4. Now don't be too alarmed with the fraction, just think about this as 8 and that is 4. So the common base between those guys is going to be 2. So our job right now is to rewrite each of these guys to be 2 to a power. So that's going to be 2 to some power and then raised to the 7x minus 2. And 4 is going to be 2 to a power and then raised to the 19 minus 6x. Alright, so here are the tricks that we've been playing. If I look at this right here, if I look at 8, what is the power of 2 that gives me 8? Well, it's 3, right? 2 to the third is 3. In order for it to be in the denominator, though, that's where the negative powers come into play. So this is actually 2 to the negative third power. And then we look over here at 4. What's the power of 2 that gives me 4? Well, that's 2 to the second power, like that. Alright, so now we see that we have the same base on both sides, but we have to reconcile this. We have a power raised to a power on both sides. And when we have a power to a power, we multiply. So this becomes 2 multiplied, so that's negative 21x plus 6. And on the right side, you're going to distribute the 2, so that's 2 times 19, 38. 2 times negative 6x is minus 12x. So we finally have each side of our equation written where we have the same base. And if we have the same base, that means those powers have to then be the same. So that becomes our equation. Negative 21x plus 6 is equal to 38 minus 12x. And at this point, we just have a nice linear equation to solve. So we need to get all the x's to the same side, and I want to do this in such a way so that the coefficient is going to be positive. So that means I'm going to add 21x. And you don't have to do it this way. If you want to move the 12x to the left, you can do that. It all ends up being the same at the very end. So if I move my variables to the right, I need to move my constant to the left by subtracting 38. Those guys go away. And so now I have negative 32 is equal to 9x. And it's just a simple little step here. Divide both sides by 9. And we have that x is equal to negative 32 over 9. So once you get these guys to have the same base, you can then equate their powers, and you have a nice linear equation to solve. And that's how a lot of these equations work. We're not really trying to hurt you in any way, just getting you to rewrite each side so they have the same base. Now let's take a look at the next example that we have. If I take the fifth root of 49 is equal to 343 raised to the 2x plus 9. Alright? Well, we have to find that common base. And if you look at something like 49, you know that guy breaks down to be 7 squared. So our hope is that we can somehow rewrite 343 as a power of 7. And so maybe off to the side you just do a little reminder here. So 7 squared is 49. Well, what's 7 to the third? Well, if you've got a power sheet, you can just go down that list of cubes and you'll find out that 7 to the third is 343, which works perfectly here for us. Now, the trick is how do we rewrite each of these? Now, I feel like the right side is the easier guy to rewrite because 343 we just saw is 7 to the third, and then that's raised to the 2x plus 9 power, like that. On the left side, it's a little bit more difficult because of the radical. Now, if I don't have the radical here and I just have 49, you would say that this is 7 squared. But since I do have a radical, that index becomes the denominator of my power. So it becomes 2 over 5, just like that. So 7 squared is the 49. That denominator of 5 is the index for that radical. All right. And so now we have a power to a power, so we're going to multiply these guys. 7 to the 2/5 power equals 7. Make sure you distribute. That's 6x plus 27. And as we've mentioned, as soon as you have the same base on both sides, you can then set these guys, or you can set their powers equal to each other. So that means 2 over 5 is equal to 6x plus 27. Now, to avoid dealing with a lot of fractions, what we can do is just go ahead and clear out the fractions and make our lives a lot easier. So the only denominator that we have is 5. So if I multiply both sides of the equation times 5, then I won't have fractions to worry about. So here, those 5's reduce, and I just have 2. On the right side, you have to make sure that you distribute. 5 times 6x is 30x. And 5 times 27 is 135. All right, so now we're out of the exponents. We are away from all of our fractions, and it's just a matter of, can you solve this nice linear equation? And I know you can. You just need to move the 135 to the other side so that you can get all of the constant terms together. So we have negative 133 is equal to 30x. And then we can finish this by dividing both sides of the equation by 30. And we have x is equal to negative 133 over 30. You can try to reduce that, but you're not going to be able to do anything with that. So this is as reduced as it gets. Okay? So let's do a couple more. We've got plenty of room here on the paper for that. So let's see what else we have. All right, so here we have 125 raised to the 2x minus 7 is equal to 1 over 25 raised to the x plus 3. All right, so I hope you can identify that the common base here on both sides is going to be 5. So 125 can be rewritten as 5 to the 3rd. And then that's still raised to the 2x minus 7. Again, with a fraction, we don't need to worry about that. You know that you can rewrite 25 to be 5 squared, but since that 25 is in the denominator, that means 5 to the negative second power, like that. And then that is raised to the x plus 3. Okay? So as long as you know your powers, you're going to be fine. Remember, if it's something that ends up in the denominator, that's going to have a negative attached to it. And so now we have powers to powers, so we're going to take these guys and multiply them. Step by step, if you do it the same way every time, you're going to be fine. So that's 5 to the 6x minus 21. Over here, when you distribute the negative 2, that's negative 2x minus 6. And you have the same base on both sides, and as we've seen with the last two problems, that now means that we can set their powers equal to each other. So 6x minus 21 equals negative 2x minus 6. A nice linear equation, the kind of stuff you just dream about. I'm going to add 2x to both sides. And while I'm moving the variable to the left, I'm going to add 21 to move my constant to the right side. Alright, so now we have 8x is equal to 15, which means that x is equal to 15 over 8. That wasn't so bad, was it? Think about what the difficult problems may be. Maybe converting from the fraction to the exponent, or to the exponential form. Again, 25 is 5 squared, but since that 25 is in the denominator, That's why you have the negative. And you also need to know that 5 to the third is 25. In the past, I have had students say very wrong things about powers. 5 squared is 25, not 5 to the fifth. So don't say 5 to the power of 5. That means 3,125. You don't want to go there. That's not what that means. Know how your powers work. All right, here's the last one we have. 16 raised to the x minus 2 is equal to the cube root of 32. If we can identify the common base, then we're going to be in good shape here. So between these two, you might think that 4 is the common base because 4 squared is 16, but you can't raise 4 to a nice power to get 32. So if you break it down even further, you're going to find out that 16 is based off of 2. It's 2 to the fourth. And if 16 is 2 to the fourth, that means 32 is 2 to the fifth power. Now that's just 32, but we saw this up above where I can say that 32 is 2 to the fifth and then take the index here, and that becomes the denominator of the power, just like that. So you don't have to go through like a big elaborate process to get there. You know that 2 to the fifth is 32. That index becomes the denominator, and that's it. All right, so over here we have distributing that needs to happen. So 2 raised to the 4x minus 8. Please make sure that that 4 multiplies to both of those terms. And this is again equal to 2 to the 5/3 power. All right, these guys now have the exact same base. So we can set the powers equal, so 4x minus 8 is equal to 5/3. And we saw this up above. If you don't like the fractions here, and again, it's probably easier to work without them, go ahead and clear them out by multiplying times the common denominator, which is just 3. So if I multiply both the left side and the right side by 3, and again, noticing why we do that is so that the denominator can reduce. Distribute on the left, we get 12x. Minus 24 is equal to 5. And then it's just a few steps until you're done. All right, so let's add 24 on both sides. All right, 12x is equal to 29. And then one final step. Divide both sides of the equation by 12. Reduce if you can. However, 29 over 12, that's all you can do. And there you have it for solving some exponential equations.